Welcome to question 14 from the 2020 TMUA paper 1. The question tells us that the area enclosed between the line y equals m times x and the curve y equals x cubed is 6. Using this information, we are asked to deduce the value of m, and we are given 6 options. Pause the video here, read through these options, and have a go at answering the question for yourself. Okay, well let's begin by drawing a sketch of the setup. So we have the straight line y equals mx, which we'll draw like this, and we have the curve y equals x cubed, which looks something like this, and we're told that this area which is enclosed between them is equal to 6. We'll label the intercepts of the two curves as plus a and minus a. In case you're wondering why we've decided in this sketch to draw y equals mx with a positive value of m, and thus the positive gradient, is because otherwise there is no area enclosed between the curve y equals x cubed and the line y equals mx. So we know that m must be positive by the fact that there is some area enclosed. So yes, this area is the area of the region shaded in green in this diagram, and we're told that this area is equal to 6. But what can we notice? Well, everything here is totally symmetric about a rotation through 180 degrees, which tells us that this area here and this area here are exactly the same, and therefore the fact that this total green area is equal to 6 is the same as saying that this small green area here is equal to 3. So how can we write down that information? Well, this area here is the integral from 0 to a of the line y equals mx minus the integral from 0 to a of the curve x cubed. So we can therefore write down the statement mathematically that the integral of mx minus x cubed from 0 to a is equal to 3, and that tells us that this area here is equal to 3. So now that we have this, can we integrate it? Well, yes, because it's a polynomial, so we just add 1 to the power and divide through by that resulting power to integrate each term. So we're left with a half mx squared minus a quarter x to the 4, and we're evaluating at a and 0. So if we plug in 0, we'll just get 0, and if we plug in a, we get half ma squared minus a quarter a to the 4, and we know this whole thing is equal to 3. Now this equation has two unknowns, which are m and a squared, so is there any way that we can write this just in terms of one unknown? Preferably we just want to write this in terms of m, because ultimately we want to identify m as one of these 6 options. So how might we go about doing that? Well, we've just defined a as the point at which the curve y equals mx and the curve y equals x cubed intercept. So therefore m times a must equal a cubed, because that's the value of y at this point. And if we divide both sides of this equation by a, that's just the same as saying that m is equal to a squared. So we can now rewrite this equation with m equals a squared, and that tells us that we have a half m squared minus a quarter m squared equals 3. Now a half minus a quarter is just a quarter, so we just have a quarter m squared equals 3, and therefore m squared equals 12, and m is thus the square root of 12. And if you look back at the options above, then this is just telling us that m is equal to 2 root 3, which is option E. So the answer to the question is option E.